Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom. So learn physics at your convenience. Let us start our today's lesson. The topic is collision. Students, it is very important topic and mostly it is mathematical topic. First of all, look at these diagrams. When two balls collided, two cars collided, or a car is collided with a tree, or again two balls are collided. What is collision? Collision is defined as when two bodies come close to each other. Look at these diagrams such that they exert force on each other. It is called collision. So, for collisions, it is not necessary that the bodies should touch physically. What is necessary? It is that they should exert force on each other. For example, when similar poles of a magnet are brought close to each other, they repel each other without touching. So that is also an example of collision. Students, collision is of two types. First is called elastic collision. What is elastic collision, or what is the definition of elastic collision? It is the collision in which kinetic energy, remember, kinetic energy and momentum both are conserved. The collision between atomic and subatomic particles are the examples of elastic collision. Second is inelastic collision. Students, it is a collision in which momentum is conserved but kinetic energy is not conserved. The collisions that we observe in our everyday life are the examples of inelastic collision. Today, we will discuss elastic collision in one dimension in details. Students, let us consider two balls of masses m1 and m2 are initially moving with velocities u1 and u2. Means u1 and u2 are their velocities before the collision. When they collided and after collision, they move with velocities v1 and v2. Since it is elastic collision, so applying laws of conservation of momentum and kinetic energy on this situation. First, applying law of conservation of momentum. Momentum of the system before the collision should equal to the momentum of the system after the collision. Mathematically, m1 u1 momentum of the first mass, m2 u2 momentum of the second mass, and m1 u1 plus m2 u2 represents the total momentum of the system before the collision. It should equal to the total momentum of the system after collision. Rearranging this equation, taking m1 v1 on the left side and m2 u2 on the right side. Now taking m1 common on the left and m2 common on the right side and mark it as equation number 1. Remember it, note it, we will recall it after few steps. Now applying law of conservation of kinetic energy. Total kinetic energy of the system before the collision should equal to total kinetic energy of the system after the collision. Again, rearranging this equation, taking m1 v1 on the left and m2 u2 on the right side, and again taking half m1 common from the left side and half m2 common on the right side. Half will be cancelled with the half and we are left with the equation m1 u1 square minus v1 square equals to m2 v2 square minus u2 square. Student, look carefully on this equation. What is it? A square minus b square. You know how to open it? Yes, a plus b and a minus b. Same is the situation here. We just open this formula and we can write it u1 minus v1 and u1 plus v1. Similarly, v2 minus u2 and v2 plus u2. I mark it as equation 2. Now dividing this equation 2 with that equation 1. This was equation 1. I divided equation 2 with equation 1. This term m1 u1 minus v1 will be cancelled. m2 v2 minus u2 will be cancelled with this, and we are left with u1 plus v1 equals to v2 plus u2. Just rearrange this equation. u1 minus u2 equals to v2 minus v1, equation number 3. Students, it is very important equation. This equation shows that the speed of approach u1 minus u2, the velocity with which they were approaching each other before collision, is equal to the velocity with which they are receding from each other after collision. Speed of approach is equals to speed of recession. I mark it equation number 3. Now students, we will solve equation 3 with equation 1 for first we will use it for finding the value of v1 and then for v2, and we can find the velocities after collision for different situations. Now first we will find, to calculate velocities after collision, we will find the value of v2 from this equation number 3, and we will insert this value in equation 1. m1 u1 minus v1 equals to m2 u1 plus v1 minus u2. This was the value of v2 that we inserted in equation 1 minus u2, multiplying m1 in the bracket on both sides, and again rearranging this equation, we get m1 u1 minus m2 u1 equals to m1 v1 plus m2 v1 minus 2m2 u2. Now from these two terms we will take v1 common, and from these two terms we will take u1 common. Solving this equation for v1, taking v1 on the left side and rest on the right sides, dividing both sides by m1 plus m2. Now m1 plus m2, this term will be cancelled, and we will get v1 equals to m1 minus m2 over m1 plus m2 into u1 plus 2m2 over m1 plus m2 into u2. It is equation A that gives the velocity after collision of mass m1. Similarly, again from equation number 3, we will find value of v1, and we will insert, just rearranging the equation number 3, and we will insert this value in equation 1 and solve it for v2. So putting this value in equation 1, m1 u1 minus v2 plus u1 minus u2 equals to m2 v2 minus u2. This was equation 1. I just inserted the value of v1 here. Now multiplying m1 and m2 within the bracket, we will get this. Combining these two terms, m1 u1 plus m1 u1, 2m1 u1, taking this on the left side, 2m1 u1 plus m2 u2 minus m1 u1, and I took this on the left side, and here this term is taken to the right, again taking u2 common, and here from these two terms we will take v2 common. Solving it for v2 by dividing m1 with m1 plus m1 plus m2 on the both sides, this term will be cancelled, so v2 is equals to 2m1 over m1 plus m2 into u1 plus m2 minus m1 over m1 plus m2 into u2, equation B. Students, equations A and B are used for different values of masses and under different conditions, whether the target ball is at rest and masses are same. If m1 is greater, if m2 is greater, we will insert these value here, and after solving these equation we can find the velocities after collision. Student, this is all about the elastic collision in one dimension. I hope it is clear. Students, thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.